Welcome to the first episode of the second season of Zeroing In. I am Arunes, and joining with me today as co-host is Naman Jain, who pursued his dual degree in solid-state physics from IIST. Currently working at the Indian Space Research Organization, he has carried out his research work closely with our guest. Today, we are in conversation with a research pioneer from the field of fundamental physics, whose work expands beyond any conventional boundaries set for the discipline. He pursued his PhD from the Tata Institute of Fundamental Research in Mumbai and then went on to pursue his postdoctoral works at various universities and research facilities, including the University of Aarhus, Denmark, and the University of Paris, CERT. He shortly worked at the Indian Institute of Technology, Madras, as an assistant professor before joining his current position at the Indian Institute of Space Science and Technology. His research work has treaded unconventional paths and continues to create new avenues while probing the secrets that the fascinating everyday world hides from us. He also partakes in the development of scientific payloads and technologies for a plethora of ISRO missions. His ways of seeing the world inspires a deep sense of wonder, which he communicates through his words and his work alike. In our conversation with him, we discover more about his journey and his perspective of looking at things fundamentally. We are really delighted to have here in conversation with us Dr. Umesh R. Kadhane.
Thanks, Arun. That was rather elaborate. Yeah, thanks a lot. I miss talking to all of you. When Naman was there, we used to have several hours of, I don't know how useful, but rather philosophical discussions. I really do not know how useful they are, but I am fortunate. One of the benefits of working in academics is to meet young, bright people and discuss ideas, crazy ideas. You feel young again. So, yeah, thanks.
I could go on about the basically precludes of this for hours and hours, but let's start with this idea about, the whole idea of physics as a physicist is seeing the world in a complete way in some sense, loosely, I guess. And just wanted to start with this. How would you be able to explain how you see physics or what it means to you and how the meaning of it has evolved over the time?
I'll give you an example. There's a museum in, I don't know whether it is Hyderabad or Sikandrabad now, Salarjung Museum. There is a statue in that. It's called Veiled Rebecca. I don't know how many of you have seen it. It's a statue which is carved out of marble, white marble, a single piece. It's a very beautiful statue. It's a statue of a lady, and she has a veil in front of her. In spite of the fact that it is made from a stone, white stone, no colors, no paints, nothing. It's the skill of the artist. You can actually see her face. I do not know if you can perceive this, but it's very easy to have a real face and covered with a semi-transparent cloth. But this one is carved out of stone. I don't know whether I see physics alone. I don't think I only see physics. I see anything which is fundamental in that way. So much is covered, but still so much is visible. You can actually see the face of a person in a stone, covered with a veil. I think there is so much we still to understand in science, but we still see so much. I don't know, sometimes it's really amazing. So I wouldn't say it's only physics. I would say anything which goes to the fundamental why and how is interesting for me. Yeah, when I was studying science, it came in steps. Unfortunately, subjects are taught like that. Botany is taught in a certain way, zoology is taught in a certain way, chemistry is taught in a certain way. But I feel at the end of the day, take anything, any subject, I think personally, I would see it the same way. When it goes to fundamentals, I go to that depth in physics much easily compared to other subjects because the way they were taught to me. If they were taught to me slightly differently, I would have gone mad behind them as well. So yeah, there is nothing special about physics. Any subject which is fundamental, which raises fundamental questions is interesting. I don't know. That's how I think.
So, sir, on that note of fundamental ideas and concepts, there is a whole wide variety of such phenomena that we experience, on a day-to-day basis that still manages to elude our understanding of them. So say I take a reflection. It starts out as a bunch of arrows and rays in a high school textbook and develops into this entire package of boundary condition, Fresnel reflection laws, and such. Even for such a common, familiar process, we don't usually talk about what happens on its atomic scale. So, could you maybe describe the process of reflection, on a more fundamental level?
Okay. The way, again, the issue with subjects is the way they are introduced to us. The light, for example, the ray of light is always, in the school textbooks is shown as arrows. And then the moment you put an arrow, whenever the arrow changes direction, we get into trouble. We start defining things which will define the change of direction. But the reality is slightly more fundamental than that. See, usually when we write the expression, it is written that if the wave is traveling in a particular direction, say Z direction, so you will write some expression which contains Z. The other two directions we normally don't talk about, right? See, when you write expression for the electric field of an electromagnetic wave, you write e to the power ikx or ikz minus omega t. So you are only talking about the direction in which the light is propagating. You don't talk about what happens in the other two directions. And that is where the fun is, because depending upon how it behaves in the other two directions decides whether the wavefront is a plane wavefront or a cylindrical wavefront or a spherical wavefront. And what happens when such a wavefront meets any object, including atoms or molecules, is the same thing. Imagine you are standing on the seashore and a wave of water comes. Look at what happens around your feet. Something similar happens to the electric field. And then consequently, due to the connections which electric and magnetic fields have due to Maxwell's equations, something similar happens to the electric and therefore magnetic field. So imagine a plane wave approaching an atom. So this plane wave, like a tsunami, comes and some atom is standing in the wave hits it. The part of the wave remains, or in fact, the most of the wave remains as it was. It remains as a plane wave. It just keeps moving like the same wave which came from the ocean. But there are localized changes in the wavefront which occurs. Okay, and our observation of that atom or any object in the wave in the process of the scattering is entirely based on that disturbance. So that disturbance is what we try to measure. Okay, so what you say about reflection or refraction is essentially scattering, the process of scattering. So what I just now told is scattering of electromagnetic waves from an object. Now the scattered shape will acquire a form based on what is the object which is scattered. For example, if it is a cylindrical, if it's a wire or a cylinder, then the scattered wavefront will acquire that shape. So you will have one wavefront which is original one, the plane wavefront, and the other one is a scattered wavefront. And if you detect it at some distance away, what you see is a sum total of these two disturbances. The one which is undisturbed plane wave and the other is a scattered cylindrical wave. And that is what you see on the screen. That is what actually gives rise to your diffraction pattern from a slit or from a string. If you take your hair, for example, you take hair and take a laser pointer, you will see beautiful interference pattern. It's because of this, that there is one wavefront which remained plane, another one which acquired the shape of the scatterer. Now, this is a very classical way of looking at it. Being a quantum system, of course, everything is a quantum system fundamentally, but you understand what I mean. So if you take an atom or molecule, something more can happen. Instead of simply taking a linear response, simply responding to the electric field and distorting the shape of the wavefront, atoms or molecules or nuclei have some more interesting things to deal with. For example, they can actually not only distort, but produce a totally new wavelength. They can absorb one and produce another one, fluorescence, right? And so on. So it can do several things. So one is simply modification of the phase of the wavefront. Okay, that is what we use in day-to-day life. Whenever you look at somebody or you look at yourself in the mirror, basically what you are doing, you are basically sending an electromagnetic wave. All the objects around you scatter it, so basically cause changes in the phase, and then they come back and meet you. And the information about those objects is imprinted on those phase changes. So this is where the system is totally simple and linear. There is no complication. But you can have additional complications by photoabsorption process, photoemission process, Raman effect, so many different direct and indirect. Then you have nonlinear effects, like you absorb one wavelength, emit another wavelength, and so on. And these are again, incoherent effects. Sometimes you can even have coherent effects, which brings you to the new domain of quantum technologies. But well, it's not so easy to handle them, because then you have to prepare the systems also that carefully. Okay, I don't know if it answers your question, but this is how we should see interaction of electric waves. The rest is all mathematics.
There are a lot of words that are thrown in the whole jargon of when you are trying to explain, and reflections and refractions. They say that there are all these things that are happening which are quantum electrodynamical in the sense, although there is no classical explanation to all of those things. But not going there, it's still quite an intuitive picture that you paint. Indeed, as you say, everything else would account for mathematics. I just wanted to go a little more fancy, just for the superficial sense of it, and ask you again. There are all these particles that we talk about, right, in the fundamental physics and all of those things, that as we go further and further, there are so many particles coming out from the theoretical calculations. How do we confirm if we have found the smallest particle? If there is there even a way to do that? I mean, I understand it's a very superficial question, but
the issue is in the word called smallest. There was time in the history of particle physics, somewhere around 1940s and 50s. We expected that as we go to fundamentals, the number of particles which you require to describe the universe should reduce. But when they started doing collision experiments, they started finding more and more and more particles, and it became madness. I mean, you couldn't build a structure because you're getting so many particles. Now, how do you build a structure out of it? Of course, it was the genius of many good physicists who worked in the field theory and relativistic quantum mechanics. And some radical ideas started coming in when we started to go to the domain of field theory. That you understand that particles are not particles. They are also fields, or in fact disturbances in the field, just like photons. And once you perceive that idea, the size of a particle becomes irrelevant. There is no relevance to that, right? So then comes a problem that what are these fundamental fields whose disturbances are these particles? As it turned out, so many fundamental particles were not fundamental at all. They were simply the excited states of some particles, right, in the field theory. So that's how they come, right? The excited states of the field, they will give you delta particle, delta plus delta minus, so many particles. Finally, it turned out that the structure of the universe right now, standard model, is fairly compact model. Then comes the question, have we reached the limit? We don't really know whether we have reached to the limit. Because one thing is sure, that whatever is the structure right now, that is the 6 fundamental particles, baryons, then leptons, and then some bosons, is not enough. But it is one thing is sure, that you are not going to increase this set. At best, you are going to decrease it further down, right? So if I look at it this way, say there is a top quark, there is a bottom quark, there is charm, there is strange, there is electron, that is electron neutrino. If these are disturbances in the field, and these fields are whatever those fields are, if I have to come down, then I have to reduce the number of fields I require, and finally everything should come out from a single field. Okay, so all these particles should finally emerge from a single field. So whether our conventional approach will go ahead and do that, it doesn't look like, because we have gone to very high energies. We do not seem to get an internal structure of quarks or internal structure of electrons. So if at all it will come, and this is a guess right now, from a single unified field. Under different circumstances, different particles show up due to the field disturbances. But what would that field be? We don't know. What would the interaction be in that field? What is a fundamental interaction? We don't know. There are approaches. There was something called grand unification theory. It came, it went. Then came string theory. It came, now it is going. So we are right now limited. But one thing is sure, that the energy range the energy domain at which we have probed it is definitely not sufficient to do that. So 2 points here. One is we need to go to even higher energy domain. But right now, physicists do not have a number to target. See, when we went for a Large Hadron Collider, there was a number to target that this much energy is needed. For the present understanding of physics, there is a Planck limit, which is anyway not possible for coming 100 years because that is really too high energy. But we don't see anything in between so far. The second is, if at all we are going to go on to deeper understanding of this standard model, then it should only shrink further. Number of particles should only shrink further. They cannot expand. That is one thing. So these two things are for sure. When and how it will happen, well, maybe you people attempt it.
You spoke about the standard model, quarks, grand unification theory, concepts that fascinate anyone who comes across them. But when we actually try to read about them, it becomes this huge, daunting task. There is this whole bunch of subtleties that is often left misunderstood, that hides behind the intimidating math and theories behind those ideas. Say ideas like relativity or quantum mechanics. In your view, how do you think one must go about understanding these concepts and ideas?
So, to understand poetry, you have to go through 4 levels. First level is where you simply understand the words. You don't understand them. Second level is where you actually start making sense of the sentences, but you still don't understand the whole poem. Third level is when you actually understand the meaning of the poem, what it is trying to say. And in the fourth level is where you actually understand what the poet actually meant. And it can be totally different. And I can give you hundreds of examples where what is the apparent meaning and what the meaning poet actually means are heaven and hell different. So the same thing goes with any fundamental idea. Being humans, we are very curious. And whenever we hear a fundamental idea, we get excited, we get intrigued, we get enthusiastic about it. But you have to go through these 4 levels of labor before you actually can reach to the idea. Usually, people are not that patient about poetry. Whether that poetry means field theory or relativity or cosmology or anything, you need those 4 layers. Okay. Ghalib used to say, "Aah ko chahiye kumr asar hote." Okay. So it's all about an ecosystem in your head, right? So when we teach you relativity, for example, the first time we teach you relativity is actually one of the worst ways in which anybody can teach you relativity. How do we teach you? We teach you something crazy about some hypothetical experiments, measuring the length, measuring the time, and this and that. And then somehow we stretch you to Michelson-Morley experiment. And then somehow we say, suddenly out of the blue, something comes called Lorentz transformation. And then you keep wondering, what is this Lorentz transformation? By that time, the teacher has finished teaching you what is velocity of light and all. This is a very bad way of teaching. But unfortunately, when you go pedagogic teaching, these are perhaps the sort of public ways of teaching. So the problem is, when we go through these steps, we harp on the steps so much that you start getting a feeling as a student that this is what you are supposed to do. No, these are only ropes. And using these ropes, you have to climb. But the way we teach you, we just give you an impression that these ropes are what your destination is, which is wrong. These are only directions. It is again like poetry. What is written there is not what you're supposed to understand. It is supposed to facilitate you to understand what it means. When we say uncertainty principle, when we say duality, linear combination of eigenstates, when we talk about that, this interference and so on, these ideas, you're supposed to absorb them in a certain way, and these examples are supposed to help you absorb. Unfortunately, because of the exams, because of the assignments, because of the evaluation, we give you an impression that if you can, solve a problem, find out what is the proper length and what is the apparent length and the time dilation, then you have understood relativity. But then your focus is totally somewhere else. And that is where the issue comes. There are solutions to that. But so what happens to a common man or common person is this issue. We go by perception, and the perceptions change when you go through these 4 levels. Right? Majority of the students come to astronomy, majority, I'm not saying all, but majority, thinking that astronomy is about beautiful photographs of nebulae, galaxies, supernova, and things like that. There is a lot of work which goes behind it. right? When we say that this particular star is a red giant, a seasoned astronomer knows how much labor pain the whole process goes through before declaring that that star is actually a red giant. Okay, so these 4 levels of going through anything in life, anything, be it poetry, be it photography, be it cooking, be it learning physics or chemistry or mathematics, or even, love or affection or anything, personal relations. You have to go through these 4 layers. Unless you reach to the 4th layer, you really do not know. You really have not understood. The problem is people want to reach to the 4th layer by crossing the 1st layer. That is not going to happen. Even for superhumans, because aha ko chahiye kumra sar. But that's why you have to dedicate your life to learn something.
So would you like to talk about, probably in a very just a indicative manner, how your journey through these 4 stages were, probably leading to how you came into physics or how you came into academia?
There were 2 things about my childhood. First, my father, my mother, they were directly associated with a school in a town which is very infamous town, and social environment was extremely bad. But fortunately, my parents were very much involved in education. My father was not even a teacher, he was a senior clerk in the school, and my mother used to teach in that school for some time. And they were basically, my father particularly, was basically running the day-to-day activity of the school and all the administrative part. But the teachers used to come to our home and used to talk about problems and difficulties. And I had a very special interaction, special relation with my father. We used to always openly discuss things with me, openly. He never said, oh, you are too young to know this. He never said this ever in my life. Whatever came in front, he discussed. And we were in a very bad environment. So a lot of things used to come in front which you people haven't seen yet. So yes, that was one. Second, I was an extremely bad student. I used to barely manage to pass. So nobody ever had any expectation from me. My parents, my teachers, my friends, nobody had ever any expectations from me. So I had a lot of time to wonder about the world. So these 2 things were very, very important for me. Because of these 2 things, one thing happened from me from childhood was I could spend time thinking about ideas, crazy ideas, silly ideas, observations, why things are the way they are. To a large extent, because my father used to also wonder like this, and we used to discuss very often. We did not have a refrigerator at home, so we had to buy vegetables every day. So every day between 6 to 7 o'clock in the evening, my father will take a cloth bag, wear his chappal, start moving out. It was by default. There was no discussion, no permission, nothing. Even if I have an exam tomorrow morning, I will get up and go with him. And on the way, we will discuss every possible thing in the world, everything. And because of that, a habit developed that I could spend a lot of time thinking in my head. And when I was, I think, 5th or 6th standard, I started developing very keen interest in poetry, Urdu poetry. Then somewhere around 12 years age or so, I started reading about world history. And again, I could spend days and days thinking about world. So I think that process of thinking prepared me for science, because at least at the school level, science and mathematics are perhaps the most fundamental subjects you can think of. Let me tell you, geography, history, social science, all of them are fundamental subjects. Unfortunately, the way they are taught in the school, you don't really see that. Okay. But in mathematics, there's no choice. It has to be taught in a certain way, and you end up getting that impression. I consider history of Second World War as fundamental as mathematics. That's my perception. That is because I could spend hours and hours and days thinking about it. You people come from a very competitive background. You cannot have that kind of luxury, the kind of luxury I had. So to be able to cross those 4 stages for physics, I had already crossed those 4 stages in many subjects before I actually jumped to the 4th stage of physics. So I did not have to do the whole exercise again for the 4 stages of physics. By the time I entered into formal physics, I already had crossed the 3rd level. 4th level, I am still learning. I don't know when I will cross, but it's work in progress. See, often students get an impression that if I take up, say, engineering in electronics and communication, then my life is dedicated to electronics and communication. It's a very wrong perception people carry about education. Okay. Suppose you take a subject, say mechanical engineering or MSc mathematics. The subject is only an excuse to train your head for a certain level of analysis. Once you have reached to that level, and parallelly you can introduce any other subject. The only thing which is missing is the information about that subject. Once you bring in that information, your wisdom to process it at that level is already prepared. Only thing is the platform was different. That's all. Excuse was different. So these 4 layers you can cross to have that wisdom. Then changing subjects is very fast, very simple. So I had crossed several layers in other subjects before I got into physics. So it was easy job.
Interesting. But yes, sir. I actually wanted to ask about the process for you. So basically, when you think about something, some new thing, and then there's a process to execute it, and then there is this part where you see that it was exactly not what you imagined it to be. How is that process for you? And then probably after that, if you have a crazy idea in your head, which you resonate with here as well, and you remember it, then probably.
There are 2 fundamental ways in which human mind can think. One is linear thinking. Linear thinking is you do something, reach up to stage A, then follow some algorithm, process, go to step B, process, go to step C, and that is how particularly people who go through several of stages of competitive exams and all, they are trained to do that, because that's a sure shot way of reaching to the destination, right? Because there are set algorithms to go from point A to point B to point C to point D. Unfortunately, that training is very, very bad for research, because research requires the second type of, which bypasses some points, revisits some points in the opposite direction, and so on. So the ideas should come to your mind like lightning. They bypass linear thinking. They do not go by A to B, B to C, C to D, D to E. That's not how the idea comes. When you fall in love with somebody, you do not fall in love with somebody after going through the CV, getting recommendation from parents, your parents, the person's parents. No. You first fall in love. Then you find out everything else. Okay? So, an idea in science is like falling in love. And it can come any way. Suddenly. As long as your eyes are open, ideas will come to you. How you are going to convert it into something intriguing, interesting, is up to you. For example, I insist on tea. You know that. Tea or coffee. It's an absolute necessity for any research and educational institute. Absolutely necessary. And I don't mind how much time you spend on a cup of tea. When you're having tea or coffee, you're sitting with the people, like-minded people. You will end up discussing ideas. Okay. Now, of course, what you discuss depends on the collective intellect of those people. But my training is from a place like TIFR, where people discuss crazy ideas over a cup of tea on the seashore, walk and think. Many of our good ideas of research have come over a cup of tea. Many, not one, many. And many times serendipity helps you. It's serendipity, you can call it beginner's luck, whatever you call it, it really helps you. You should always go ab initio to an idea. Whenever an idea comes to your brain, don't bias yourself. Just go ab initio. So I'll tell you one story what happened. I joined my postdoc position in Denmark. I was spending time just exploring ideas. It was a big lab, lots of experiments, lots of facilities, different people doing different things. For a month, I was sort of jobless because so many things to do and all that. Then I discussed with my boss and started some experiment and so on. And I was into some crazy experiment by that time. One day evening, my boss was just 4 years older than me. So we were good friends. We are still very good friends. So we said, okay, chalo, today we will go out for dinner. We used to go sort of regularly out. He was single that time. So I was also forced bachelor. Sarita was in Italy. So I was like, okay, chalo. So one day evening, 6 o'clock, we said up to 6 o'clock we'll be in the lab and then we'll go. So I started going out and the boss said, let us go to another lab where one of his master student was doing an experiment with DNA strands. Okay. Said, okay, chalo, let us see what he's doing. I had no clue. So we went. He was doing something with the solutions, pure chemistry, etc. But using synchrotron radiation or something. It's called circular dichroism, whatever it is. Technical details are not. I asked, what are you doing? So he told this process happens. Okay, then we went for dinner, had dinner. I slept in the night. Morning, I go to boss's office for a cup of tea with boss. I said, boss, why not we do this? So I came up with some crazy idea. I am not from that field. I don't understand anything. Boss said, okay, sounds interesting. Let us try it. We tried it, and in 3 months' time, we discovered a completely new and a completely previously unknown mechanism by which actually our DNA has protected itself for millions of years. There was a time in Earth's history when there was no ozone layer and the extreme UV radiation was reaching Earth. We discovered, not a method or technique, a fundamental quantum behavior of DNA we discovered by which the DNA actually deliberately damages in a peculiar way so that the energy of that impact is dissipated, but it can repair itself correctly. So it came out of a crazy idea. And I can tell you, this is just one example. There are many ideas, many ideas. I was fortunate to have people around me who could listen to me, advise me, and help me to come out with these ideas. In fact, I was also responsible for an international fight on something related to our proteins. But okay, we solved it anyway. But yeah.
So in this whole process of understanding the ideas that you go through, is there a point where you feel like, okay, this is where I want it to be? And do you stop it? Do you stop the process at that? Or is it, how does the cycle go on?
Unfortunately, I never reached that point. I think one time I will reach to that point. And yeah. But I don't know whether fortunate or unfortunate. It doesn't end. There is no end, right? If you want 1,000 rupees, you reach 1,000 rupees, what do you think? Oh, I got 1,000 rupees enough? No. The moment you get 1,000 rupees, then 1,000 rupees are not important for you. And now you want 2,000 rupees. When you lose 2,000, you say 2,000 to theek hai, wo to aa gaya. Now let us go to 10,000. So the problem is always the same. Hazaro khwahishein aisi ke har khwahish pe dam nikle. It doesn't stop. And it shouldn't stop. It should stop only once. And after there is no need to continue.
So, sir, this fascination with DNA and biomolecules and chemical compounds, hydrocarbons, I found that a lot of your research papers involve experiments with fullerenes and other such biomolecules. Is there any particular reason why you focus so much on these hydrocarbons? Or is it just the lightning strike you were talking about?
No. Of course, partly it has to do with my training. Because, of course, when your training is in a certain area, you find it slightly more comfortable, which is a very bad thing, actually. It's a very bad thing. You should never be comfortable with anything. The day you become comfortable with a subject, you should leave it. That's my view. And I am trying to do that. Anyway, so the important thing is that these biomolecules have some puzzles of life. Okay. There are certain radical views of how life forms in the universe, not on Earth, in the universe. And in last 20 years, a lot of our information or a lot of our understanding has changed radically. About 35 years back, we thought that in our solar system, Earth is the only place where we have hydrocarbons. Okay. And now we find that perhaps we have one of the smallest fraction of hydrocarbons. There are lots of other places in our solar system itself which has a huge amount of hydrocarbons, including Pluto. A large percentage of Pluto's surface is covered with carbon and nitrogen compounds. It's crazy, but it is there. We still do not understand how these things survive and grow. People have discovered experimentally in situ on comets, people have discovered amino acids, right? And many other biomolecules. So this is one aspect, that they are very interesting problems, how they survive, why they are found so common, which, for almost 100 years of atomic and molecular physics, people most of that time believed that they can't exist anywhere else other than a well-protected environment like Earth. But they seem to be there in large quantities, not like trace. They are there in extremely large quantity. So that is one part of the story. The second part of the story, the way our body works at a molecular level is amazing, mesmerizing. The way information goes from one neuron to the other, the details in the design are amazing. And there is so much to understand in that. So that is the second aspect, how things work in our body. And then the third aspect, a very fundamental aspect. Such molecular systems are fantastic quantum systems. They have very peculiar quantum mechanical properties. And the more I dig into it, the more mysterious it looks. Okay, so that is reason I don't study them because they are very interesting molecules or they can form nanoparticles. That's not what interests me. What interests me is the way they exist, the way they behave. And that's what we try to unravel whenever we deal with them. We discovered several ways in which these molecules protect themselves, several interesting ways in which the electrons talk to each other. Well, they're interesting, but there are a lot of other interesting things also in it. Unfortunately, life is very short.
Is there a area that you wanted to work in, and then over the time, over all these experiences, still there is something that you know that you want to do and it's not yet been there, not the time?
Too many areas. I want to work in electric propulsion. I am working in electric propulsion, but still not very satisfied with it because there are so many other things in electric propulsion which can be done. That is one area. Plasma physics is something I want to do. Unfortunately, again, time is too short. Optics. I like optics very much. Couldn't do. Mechanical engineering. Fantastic, sir. I couldn't do. Mechanical engineering is one of the what should I say? Is the epitome of what human mind can do. Okay? Because again, just like other fundamental areas, mechanical also, things are not linear. Okay, you have to go sideways. That is one area. Archaeology is one area. Psychology is, history is. There is so much to do in history, and I can actually identify problems, very specific problems on which I would like to work. But unfortunately,
through all these varied interests and the disciplines and the experiences and training you've had and the kind of student you were, as you say, do you think that your teaching style or that your learning is very consciously different, or do you see anything that you consciously try to imbibe in there?
Yes, I deliberately do that. And that is because I strongly believe that no human can teach another human. We can only learn. And as a teacher, my job is not to teach you. My job is to create an environment where you will learn. We try to teach you too many things, which is such an insult to your brain. So for once, what I try to do is to challenge you to, I challenge my students. Why? Because I want them to learn. I don't want to teach. I want them to learn. If we develop this ability in people to learn, material is available everywhere around. Many times I found in my students, they did not have a purpose of learning something. And I think that is the biggest problem. When a student comes to me, I want to know what is his purpose. What I fail to see in most of those cases who leave this opportunity is the loss of purpose. I do not see a personality in them. And that is what I try to create in my students. I try to create an ego in my students. Once they build that personality, nobody has to teach them anything. They will learn. They are capable. What I miss in my students is most of them do not come with a purpose. And for a human, if you don't have a purpose, it's like a intercontinental ballistic missile with a megaton nuclear warhead, but no guidance, right? I purposefully make fuzzy statements, sometimes confuse you. Purposely I do that. Because, see, for those who are going to work for the exam and for marks, they know where the textbook is, where the notes are, they can practice. I tell them what to do. In the class, I give sufficient information to find out what to do and how to get pass in the exam. So no problem. But there will be a small fraction of egoistic people who will say, what nonsense is this? This is not correct. Let me challenge this. Very few people challenge actually. One should not do that. Everybody should challenge. But the style in which I teach, I specially tune for the personality development of my students. I don't want to make them physicists. I don't want to make them engineers. I don't want to make them mathematicians. They can do whatever they want. If they become a cook, I will be very happy. I will come to your restaurant if you open one. But I want you to develop a personality, because I find most of the students who join in our higher education institute, they do not have personality. You need a strong personality. Otherwise, you are just an unguided, nuclear-tipped, unguided missile. Very potent, very powerful, but simply doesn't know why and where. So that is the basic thing. What else you learn from my classes? Classical mechanics, quantum mechanics, molecular physics, or solid state physics. I don't care. You will from me, or you will learn from somebody. There are better teachers than me, so no problem.
Yes, sir. So is that what you expect of your own students?
Yes. I want my students to be mad. When you go to my stage, you will learn. You need mad people. And it is really great fun, because I have worked with several absolutely mad people. One of my mentors, a very senior professor, he died 2 years back. Michel Barat from Paris University. He interacted me from my PhD days. Then I spent some time also in his lab in Paris. And just a few months before his death, he started having this problem with his memory. He started forgetting things. He couldn't remember a lot of. And you know what he told to his wife? In that condition, he told that if I cannot remember my physics, then I have no purpose to live. And he died the next day. Right? And this is just one example. I have worked with many such crazy people. And once you see them, you want your students to be as mad as they are. You people have no idea what you can do. You have absolutely no clue about your capabilities, how powerful you people are. It's very sad to see that. To see the class of 20, 22 or 150 or even 160 students sometimes, and feel that helplessness, to see why are you wasting your life? You have any idea what you're capable of. So I hope that at least a few of you will wake up and say, why should I waste my life like this? Let me do something much bigger, much better. So I want my students to have personality. And I try very hard to develop that. Very hard. Whether you do any good with that or not, I don't care. I try to make people aware of themselves. How much science you will learn, I don't know. How much physics you will learn, I don't know. But you will be a different person. And all my projects, all my experiments, all my interactions with students, there is no physics, no engineering which is behind it. I am just operating on your personality. That's all. Physics and engineering I do for myself, not for you.
This is what that I just wanted to ask, that you actually brought it up, that you talk about the madness and the craziness and everything crazy in the world. And there is something that you talked about, and I think that goes to philosophical lines, and that's why I wanted to bring it up probably at the last. What do you think, what is the sense of purpose that there is in people? Or is there something, you talked about the poison. That's something that, one of the 1,000 things that stayed with me. And I think that's just something that I wanted to bring up, if there is.
Poison. Yes, poison. Yes. See, finally, at a fundamental level, our existence is our perception, right? At a pure psychological way looking at it, our existence is our perception. If our perception stops, our existence lost, right? When we sleep or sometime in life we faint, our perception stops and then we don't exist for that much amount of time. So if that's all what life is, then how does it matter what I do in life, right? Then just sit back and enjoy what is happening. Now for this enjoyment, I always used to tell, I think particularly to you, is to everyone must have a poison. Okay, everybody, in English there is a phrase, "What's your poison?" Meaning when some guest comes to your home and you want to offer some drink, it could be tea, coffee, coke, or alcohol, or whatever it is. Which type of alcohol? Wine, whiskey, whatever. They will say, "What's your poison?" Okay, and somebody asked me, "What's your poison?" And I couldn't answer. I couldn't decide what to tell. So that stuck here. That's one thing which I always try to tell each one of my students who are close to me, that you should choose one poison at least. And then you should choose that and spend your life behind it. There is a very nice line which is said by Sahir Ludhianvi. I don't know how many of you will understand it, but it's something perhaps the best a human can write about poison. So he said, मैदान वफा दरबार नहीं, यहाँ नाम व नसब की पूछ कहाँ, आशिक तो किसी का नाम नहीं, कुछ इश्क किसी की जात नहीं, अगर बाजी इश्क की बाजी है, जो चाहे लगा दो डर कैसा, गर जीत गए तो क्या कहना, हारे भी तो बाजी मात नहीं. If you spend your life behind your poison, whatever that poison is, there is no loss or gain. You just follow it. But average human beings are very fearful people. When parents send their children to 10th or plus 2 or engineering or BSc or BCom or whatever, they want job guarantee after 5 years or 3 years or 4 years. So humans are generally fearful. So many of your parents would actually get very angry if I propagate such silly ideas. But yes, you should find your poison and then spend your life just getting intoxicated with that poison. The rest is immaterial. The rest has no meaning. Just matter of finding the right poison for you. I don't know whether I have found one, okay? I'm telling others to find. I don't know whether I have found. But whatever I am intoxicated with, I am happy with. So, मैदान-ए-वफा दरबार नहीं.
I think these couplets from the ghazal are the ones that I probably will remember by heart for a long time. But how do you understand, how do you see it, if there's something like that?
I can tell you, you can see in the behavior, in the body language, the face, in the eyes of that person. He or she is truly intoxicated with their poison. You will see it in their behavior. I just hope one day you will see it in me as well.
I think looking at you, we can believe that it exists. Thanks a lot.
This was Zeroing In with Dr. Umesh R. Kadhane. We extend our sincere gratitude to Dr. Kadhane for sharing stories about his journey, his beautiful insight and elaborate ideas, along with Naman Jain, Fenil Shah and KVNG Vikram for collaborating on this episode on behalf of the Zeroing In Season 2 team, which included Murala Aman Naveen, Kandan Narayan, Kriti Raj, Shreya Mishra, Sean Ethan Chaudhary Fangcho, and I am Arunes. Thank you for listening to this episode. Zeroing In is a non-profit initiative by the Alumni Association of the Indian Institute of Space Science and Technology, Thiruvananthapuram. If you have any suggestions, you can write to us on zeroinginpodcast@gmail.com or contact and follow us on our Instagram and Facebook handle @zeroinginpodcast.